Hello everyone, this is Dr. Webb, and right now we're going to look at some applications of derivatives that pop up in real life. We're going to focus on a couple of examples. So all of these are going to be coming from the definition of the derivative, which wrote out in a bit of shorthand here. So just remember that the derivative of a function is equal to the limit of the change of the function divided by the change in x. So this is top here, delta f. This is the change in f. And I wrote in shorthand here, really this is the same thing as x plus delta x minus f of x. And then the bottom is talking about the delta x is talking about the change in x. Okay. And so by the idea of a limit, the f prime, the instantaneous rate of change, is going to be very close to what the ratio delta f over delta x is when x is very small. And so remember this ratio right here, this is talking about an average rate of change. And so what this sentence is saying is that f prime of x is roughly going to be the average rate of change when delta x is small. And so the underlying idea, average rate of change is about the derivative. Okay, and so when we look at this, this is still change in f over change in x. So we can rearrange this a bit, and we can get then that the change in the function is roughly going to be equal to, well, the derivative times the change in x. So this is the derivative times change in x. Okay, and this way of thinking about things, it actually has a special name in math. It's not too important, but this is what's sometimes called a differential. But don't worry too much about that. So let's do a straightforward example. Let's be thinking about velocity. Same idea as speed. Okay, and so for this we're going to let s of t represent the distance traveled at time t. So delta t then is talking about the change in time. Delta s is going to be the change in our function, and so our function here is talking about distance, and so this is our function in this setting. And so then the derivative at t, this is going to be talking about the instantaneous velocity at time t. And so you can think about if s of t is tracking how the distance traveled by a car, then s prime of t is going to be looking at the instantaneous velocity. So that's going to be looking at kind of what you'd get from the speedometer, how fast the car is moving. Okay, so let's do just a really straightforward example. Okay, so we're going to be, you're currently driving 70 miles per hour. Approximately how far will you travel in the next 15 minutes? Okay, so the only information you have so far is that right now you're traveling 70 miles per hour. So what does it make sense to assume? Well, for that 15 minutes, you're going to be traveling 70 miles an hour. So we are assuming that we're going to be traveling 75 miles per hour for the next 15 minutes. Right. And so here, this is a really straightforward problem, right? It's not going to shock you. This is how we do it. We're going to take 70 miles per hour, multiply it by, well, what is 15 minutes? 15 minutes is 1/4 of an hour. And then out of that, we get 17.5 miles. Okay, so this is a calculus class, so let's think about how we think about this in terms of calculus. Okay, so what is this 75 miles per hour talking about? Right? So it's talking about speed. So if we think about S of t being distance traveled, same as before, well then what's 70 miles per hour going to be talking about? Well, that's the value of the derivative, right? So this 70 miles per hour right here is our S prime of t. Okay, we're talking about traveling the next 15 minutes. What's that talking about? Well, that's talking about a change in time. Right, so that 0.25 of an hour is talking about change in time. And then what we get out of it is this 17.5 miles. Well, that's how far additionally we've traveled. So that's talking about change in distance. And so that's our delta S. And so to clean this up, deep down what this is talking about is exactly what we saw in the last slide, that the change in distance is equal to the derivative times the change in time. Okay, so this really is a concept that, although maybe you haven't used these technical terms to use it before, I mean, really it is something that we use every day. Okay, so another common place this pops up, especially if you're interested in business types of things, is in the cost function. So we've talked about the cost function before. For a company, C of X, that's going to represent the total cost to produce X items. Right, so in this setting, delta X, the change in X, that's going to represent the change in the number of items produced. And then delta C, C is our function, and so that's going to be the change in the total cost. Okay. Well, what then does the derivative of C tell us about? Okay, so this is, we think about this, the derivative of C, this is talking about the instantaneous change in the costs. And we have a special name for this. We call it the marginal cost, right? So given a cost function, its derivative is the marginal cost. So derivative of cost is marginal cost. Okay, so let's focus on this marginal cost function. C prime of X, it is the instantaneous range of change of the cost. So what exactly does that mean when you're making something, right? You can't, you make one thing, two things, three things. You don't really make decimals worth of things. So what does that kind of mean when we're going through and taking this? Well, if we go back and think about, this idea that we've been using for all this video, that the change in cost is roughly going to be the derivative times the change in the number of items, right? Well, what's the smallest that we can make delta X? So what's the smallest? Well, if you're changing the number of items, you can't really make, 1/100th of a new item. You're really going to make a whole thing, right? And so the smallest is really going to be setting delta X equal to 1. Well, if we set delta X equal to 1, so we're thinking about it, this is thinking about making one more. So making one more item. Well, if we set delta X equal to 1, what does this equation become? Well, it's just the change in cost for one more item is about equal to that derivative there. Right? And that really is the best way to think about marginal cost. So marginal cost is roughly the additional cost to make one more item. So that one more item is, we're really thinking about there, setting delta X equal to 1. Okay, now the marginal cost is very much different than the average cost. So the average cost, how do you get the average cost of something? Well, you're going to take the total cost and divide it by the total number of items. Well, what's the total cost? Total cost, that's our cost function. Our number of items is just x. So really, total cost divided by number of items, this is the cost function divided by x. So you can tell this is definitely not, in general, c prime of x. Okay. So what does average cost tell you? Well, for average cost, it's like after you make a bunch of stuff, you take how much it costs to make that, divide by the number of things you get. That's your average cost. So it's like after you make a bunch of items, it's how much on average it costs to make each one of those. Okay, how is that different than marginal cost? Well, marginal cost will tell you how much more it will cost to make one more. Okay, and quite often the value of this is very much different than average cost. And I think in the practice problems I'm going to give you at the end of this, we'll see, you'll be able to go through and see an example of where that happens. Okay. So we've been talking about the cost function. When we talked about the cost function before, we also talked about the revenue function. So is there such thing as marginal revenue? And what exactly does that mean? Okay, so what about marginal revenue? Well, we let r of x be our revenue function. So this is the total revenue made by producing x items. Well, then going through the same idea as marginal cost, to get the marginal revenue, we just take the derivative of that. So r prime would be the marginal revenue. Well, what exactly is that going to mean? Well, so same idea as before, it's going to be the additional revenue you make by producing one more item. Well, if you make one more item, you make revenue off of it. How do you make it? How do you make that additional revenue? Well, you make it by selling it. So this is how much more you get for selling that one more item. So really that's equivalent to the price you can get for that one additional item that you sell. Right? So r prime of x is going to tell you about what is the price you're able to sell each additional item for. That is all for this video, and I will see you again soon.